Hello everyone. In this video we're going to be solving a nice differential equation. Y is a function of x and we have dy over dx equals y minus x squared. And we're going to be finding an expression for y in terms of x. So let's get started. So when you have an equation like this, obviously you can go ahead and expand the right hand side, and that's going to give you y squared minus 2yx plus x squared equals y prime. Let's just go ahead and write this as y prime now, right? And then where do you go from there? This is kind of like a interesting equation because you have the derivative of y on one side, but on the right hand side you have y squared, y together with x, so on and so forth. So expanding is not a very good idea. You better keep it this way, and then let's see how we can handle this. So I'm going to go ahead and do the following. Substitution, obviously, in so many different branches of math is a very useful method, and we're going to use that here as well. So let's go ahead and replace y minus x with something. How about t? T is my favorite variable these days, and if you go ahead and set y minus x equal to t, from here you get y equals x plus t. Now you got to remember, x is the independent variable, y is the dependent variable, and t, which is kind of defined as the difference, also becomes a function of x. Because think about it, if y is equal to x squared, then t becomes x squared minus x. Okay, so let's go ahead and plug this in on the right hand side, but what about the left hand side? We do need y prime, so let's go ahead and differentiate both sides, considering the fact that t is a function of x. So let's go ahead and differentiate it. The derivative of x with respect to x is 1, and the derivative of t, we're just going to call that t prime. Okay, great. Now, what does this give us if we substitute? Well, the y prime here is dy over dx. Let's go ahead and replace dy over dx with y prime, which is 1 plus t prime. So we're going to get 1 plus t prime equals t squared. Great. So this looks pretty simple, right? Or at least we have a single variable, right? That's kind of nice. Now, let's go ahead and isolate t prime from here. Since that's so easy, t prime becomes t squared minus 1. Now, you cannot just integrate both sides of this to find t. Why? Think about it. Okay, that would be a good question, right? Let me not answer right now. So here's what we're going to do. We can't just integrate both sides. If we did, it would look like this. T equals t cubed over 3 minus t plus a constant. Would that work? Check it out. Anyways, so that doesn't work. And you can think about why. Let me know what you think. So here's what we're going to do instead. We're going to replace t prime with dt over dx. And then this becomes a separable differential equation. Notice that at the very beginning it wasn't separable because y and x were mixed together and they were squared. So that made it even worse. But now we got a nice separable equation. So let's go ahead and put t squared minus 1 on the left hand side by way of division, and we're going to get dx on the right hand side. Great. So at this point you can go ahead and integrate both sides. That's the right thing to do, right? If you integrate, what happens? The integral of dx just becomes x plus c. And we can keep the constant on one side. You don't need constants on both sides. So let's keep it on the right hand side and try to integrate dt over t squared minus 1. How do you integrate that? So here's what we're going to do. We're going to use what's called partial fractions. So first I'm going to go ahead and factor the denominator as t plus 1 times t minus 1 from difference of two squares. And then I'll use partial fractions to separate it. Let's split this into the sum of two fractions with denominators t plus 1 and t minus 1. So a and b are unknown coefficients, but we can find them. Let's make a common denominator on the right hand side. That gives us 1 over t plus 1 t minus 1 equals a times t minus 1 plus b times t plus 1. So it's kind of like crisscross applesauce divided by t plus 1 times t minus 1. So now since we got a common denominator, we can totally forget about the denominators and focus on the numerator. Allow me to write this first on the left hand side. So that gives me a times t minus 1 plus b times t plus 1 equals 1. Now we're going to go ahead and distribute this at, bt. That's going to give me a plus b times t, and then minus a plus b. I can also write it as b minus a equals 1. So these are kind of like two polynomials. This is true for all values of t pretty much. And for t equals 1 and t equals negative 1, even though they make the denominator 0, in the polynomial form, they don't cause any issues, right? Anyways, it's not polynomial, it's rational, so it shouldn't be an issue. So now, when you look at this, you should be thinking, okay, the coefficient of t is a plus b, but there's no t on the right hand side, so this should be 0 and this should be 1. From here, b becomes 1/2 and a becomes negative 1/2. So this allows you to write the expression 1 over t squared minus 1 as, remember, it was a over t plus 1, which is negative 1/2 over t plus 1 plus 1/2 over t minus 1. Don't worry about the 1/2, we're going to take it out. So I'd like to factor out a negative 1/2, which is nice because then my first expression is going to be positive, and then the second one is going to be negative, obviously, right? You've got to be careful about that. So now this is my expression that I should integrate. So if you go ahead and integrate this, obviously negative 1/2, you can write that outside and then integrate the inside, 1 over t plus 1 minus 1 over t minus 1 dt, and then this is going to be x plus c. Remember, we integrated dx, and that's what we got. Great. So now, how do you integrate 1 over t plus 1? Think about it. The integral of 1 over t is ln t, but this is just t plus 1, so the addition of constant doesn't really make much of a difference because the derivative of 1 is 0. So this is going to be ln t plus 1. Great. And this is going to be ln t minus 1. Obviously, if we had 2t plus 1, we would have to take care of the 2 from chain rule, but this is nice. So now we're going to multiply this by negative 1/2, and that's going to equal x plus c. So there's a couple things we can do to simplify our work. We can first go ahead and multiply both sides by negative 2, and then we can actually combine these ln's into a single expression like this. So it's going to give me negative 2x minus 2c, and you can just call that 2c or not 2c. So you can kind of write it like this and then turn it into a constant. Because this is a constant, I can just replace that with k. Make sense? Now we're going to do e to the power both sides, and when we do, it's going to look like this. E to the power this equals e to the power that, and e to the power ln something is something, so this is going to give me t plus 1 over t minus 1 equals e to the power negative 2x plus k. You can also write this as e to the power negative 2x times a constant, but that's not super important. But at this point, obviously, you do want to solve for t, don't you? Okay, here's a couple of things you can do here. You can replace t with something, right? I guess it would make sense if we solve for t in terms of this. Or we can do the following. Replace t with y minus x. So we're going to get this. And then replace this with z. I'm just going to call it z for now. And then from here, I'm getting y minus x plus 1 equals yz minus xz minus z. And then I want to put everything that contains y on one side. So kind of like right-hand side would be the right side. Yz minus y equals, and then bring over the xz plus z here, and then minus x plus 1. And then here we can factor out a y. And then here we can basically put these two together and write it as z times, actually that's probably, I have a better idea. Let's go ahead and put these two together. That's going to give me x times z minus 1, right? And then plus z minus 1. And then divide both sides by z minus 1. That's going to be nice, because now the z minus 1 cancels out. Actually, that's a mistake. It's z plus 1, but then I'm going to write minus 2 to make it z minus 1. Makes sense? Correction. And then we can go ahead and just simplify this. Write it as y equals. If I split it up, this is going to give me x plus z minus 1. This is what becomes z plus 1. Actually, I should probably write it this way. Z minus 1, and then I have to add a 2 to make it z plus 1. Okay, exactly. So that becomes x plus z minus 1 divided by z minus 1 becomes 1. And finally, I'll get this. Now I'm going to go ahead and replace z with something, and that'll do the job. what was z? Z was something like e to the power negative 2x, right? Negative 2x. What was z? Okay, e to the power negative 2x plus k. E to the power negative 2x plus k. And then I just have to subtract 1 from this, and that should be the solution if I didn't make any mistakes. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.